Okay, so starting at the top, we see this chart. It says linear versus nonlinear. Linear, as you may remember, means straight line. And nonlinear would be not a straight line. Something like this, maybe something like this most often. Nonlinear is not a straight line. When looking at equations, we need ways to figure out whether this is a straight line or not a straight line, and there's some tricks for this. Looking over here at the equations, we have point-slope form, and we're going to use that today. Remember, m is slope, and x1, y1 is a point on the line, and then you can use this to determine slope-intercept form, which is y equals mx plus b. This is the one that you're probably most familiar with from Algebra 1, that you use the most, and we still use the most. M is slope, that should be familiar. B is your y-intercept, where the line crosses the y-axis. And then standard form is ax plus by equals c. Something to note about standard form, we're going to be going back from standard form to slope-intercept today, and a, b, c are integers, meaning they can't be decimals or fractions, and a has to be positive. So if you get it into this format and a is negative, then you just multiply everything by -1 to get a positive. A, b, and c are integers, so there's no decimals or fractions. In standard form. So if you have an equation in either the standard form or slope-intercept form, then you do have a straight line. And so you'll kind of see that over here. We have standard form, then slope-intercept, then x equals 3, which if you were to draw that line, it would just be a vertical line like this at x equals 3. It is a straight line, so therefore that is linear. So these are the general formats you're looking for. Sometimes you need to rearrange an equation to get it in that format to check. For nonlinear, what you're looking for to determine if it's nonlinear is exponents. If it has an exponent, it is not in a straight line. And you might be thinking, well, this has a square root. I don't see an exponent. I don't know if you recall, but a square root would be like x to the 1/2 power. So therefore, it technically does have an exponent. And then here, 1 over x. If x is in the denominator, that is not linear. X in the denominator like this would be x to the -1 power, which again, an exponent. And if you tried, If you tried rearranging this, like multiplying both sides by x, then you'd get a situation where you have y times x, and if that happens, you do not have a straight line. So that shows up on the homework where it's a situation where y is multiplied by x and it asks if it's linear. In that case, not linear. So all of these are linear if you have slope-intercept form, standard form, or just x equals or y equals, you have a straight line. And all of this with exponents, not linear. Okay, so now we're going to try this out looking at these equations. This one right here, it has x as a denominator. That cannot happen. No bueno. So not linear. Then for the next one, we do have a fraction. We're going to try to rearrange it to get it into slope-intercept form, and if we can, then it does form a straight line. So looking at this would be our y f of x equals x over 5 plus 12 over 5. Okay, now we're getting somewhere. The way we'd normally see this is y equals 1/5 x plus 12 over 5. And here is our slope-intercept form. So therefore, yes, this is linear. And then it says also state m and b. So our slope here would be 1/5. And our y-intercept is 12 over 5. Okay, most of you are looking up. I'm not going too fast. I'm okay. Okay. Next, write an equation in standard form. So standard form is the ax plus by equals c. So we have to rearrange this to match this. So in this case, we have to get the 4x on the other side of the equation. So we'll subtract 4x from both sides. We get negative 4x plus 2y equals 5. We're getting close. Remember, this cannot be negative. A can't be negative. So we're going to multiply this whole thing by negative 1 to get positive 4x minus 2y equals negative 5. Okay, next one has fractions. We don't like fractions, and we can't have fractions in the standard form. So we're going to get rid of those fractions by multiplying this whole thing by the least common multiple of 3 and 4. And that will get rid of both of those fractions at the same time. That number is 12. If we multiply this whole thing by 12, we'll get rid of those. And what does that look like? It means we have to multiply each term by 12. So we're going to do 12 times 1/3, and I'm just going to kind of do it off to the side. 12 times 1/3. So 12 over 1. When you multiply fractions, you multiply across. But before I do that, I'm going to simplify. I notice 3 and 12 can both be divided by 3. So divide that by 3 to get 1. Divide this by 3 to get 4. 4 times 1 is 4. 1 times 1 is 1. So we get 4. So this would be 4x equals. Then we do 12 times 8, 96. And then we need to do 12 times negative 3/4. So again, doing this off to the side, 12 over 1 times negative 3/4. Yes?
Are you multiplying the whole thing by 12 or just
Each term.
Everything.
Everything. Yes.
Can you repeat the steps from the beginning because it was kind of fast?
Okay, like when I put the 12 there?
No, like after that, like when you. Multiply.
Okay, so here. Reverse. Okay. So in order to get rid of that, the fractions, I'm going to multiply by the least common multiple of 3 and 4, which is 12, and that will get rid of both of them at the same time. So I'm going to multiply everything by 12, multiplying each term. My first term that I have to multiply is 1/3 x, so I'm going to do 12 times 1/3. When I multiply fractions, I need to put a 1 under the whole number, and then you would multiply across, but before I do that, I'm going to simplify. Have your teachers taught you how to simplify fractions when you're multiplying? If you have a top and a bottom number with the same common factor, you can divide by that common factor. So divide by 3 to get 1, divide by 3 to get 4, and then multiplying across is just 1 times 1, and then we get 4. So this is only for the first term. It's 4x. Then 12 times 8 is 96. And then I need to do 12 times negative 3/4. Simplifying this, both 4 and 12 can be divided by 4. So I get 1 and 3. 3 times negative 3 is negative 9 over 1, which is negative 9. So now I have negative 9y. Now I just have integers, which is good, but I need to put my y over on the other side to match the ax plus by equals c format. So I'm going to add 9y to both sides. 4x plus 9y equals 96. And then I'm done. Yes.
So do the 4x and 9y or the ax plus by have to be ax plus by or can it be by plus ax?
Well, the x would have to be first.
Okay.
Yeah. Standard form has it in like alphabetical order, so. Next, Now we're going to find x-intercept and y-intercept, or y-intercept and x-intercept. Y-intercept is the point where the graph crosses the y-axis and where x equals 0. So where x equals 0 and where it crosses the y-axis might be like right here. So that's what we're looking for. And then for x-intercept, a point where the graph crosses the x-axis and where y equals 0. So wherever this crosses the x-axis like that. It gives us an equation here. And we're going to find the y-intercept and the x-intercept. So the y-intercept is where x equals 0.
How do you know where to plot those 2 points?
I was just showing an example. Erase it.
Oh, my bad.
Yeah, you're good. Yeah, we're going to find the exact points. So y-intercept is where x equals 0. X-intercept is where y equals 0. And then we are going to plug in 0 for x in this equation. So 2 times 0 plus 5y minus 10 equals 0. And then 2 times 0 is just 0. Add 10 to the other side. Y equals 2. So that means my coordinates for that would be 0, 2. So I can plot that now. 0, 2, right here. And then for my x-intercept, that'll be where y equals 0, so plugging in 0 for y. 2x plus 5 times 0 minus 10 equals 0. 5 times 0 is just 0. Add 10 to the other side. 2x equals 10. Divide by 2, and x equals 5. So 5, 0. And then last step is to graph it. So one way to graph this would be to rearrange it into slope-intercept form and then graph it. The other way to graph it would be to find the x and the y-intercept and then graph those and graph the line. Okay, and the next page. Are you ready? Okay, over here, now we are graphing lines. Sometimes they give it to us in the format that we can graph right away. Sometimes we have to rearrange it to graph it. Here it's saying graph the line, and they give it to us in slope-intercept form. So just reviewing, this is your y-intercept, and you graph this first. So we'll plot our y-intercept at -2. And then this is our slope, the 4. So that's slope, which would mean up 4 over 1. So from this point, we'd go up 4, 1, 2, 3, 4 over 1. We could graph it with just those 2 points. If you wanted to continue your points, just keep going up 4 over 1. 2, 3, 4 over 1. And then we will graph that line. For the next graph, we don't quite have it in this format yet, so we're going to have to rearrange it to get it there. I need y by itself, so I'm going to divide that by 2, and then whatever I do on this side of the equation I have to do over here. So I'm going to divide all these by 2. And then I get y equals -1/2 x plus 4. And then I will graph this. Y-intercept is 4. And then the slope is -1/2, so that means down 1 over 2. And you can continue, but once I get a few points, I'm good. Whoa. Okay, so on this one we had a positive slope, positive 4, so it's going up and to the right. That makes sense. This one had a negative slope of negative 1/2, so it should go down and to the right. And then number 8, x equals negative 3. So we plot a point at x equals negative 3 and maybe more points at x equals negative 3. X will always equal negative 3, so our line is just a vertical line.
That's undefined.
Correct. Good call. Yes, undefined.
Why is that undefined?
Because it's a vertical line.
What was your slope of the line? Like, how did you plot the other point?
For these, this one was negative 1/2.
Right.
What's that?
The one, like, you put points on the vertical line.
Oh, just x equals negative 3. X will always equal negative 3. So technically it's all the points on that line.
Oh.
Yeah. Katie. Katie. I don't know. I think that's her name. Katie. She keeps leaving her notes.
She took the pass.
I know, but she should ask. She wasn't here on the first day spiel where it says, don't take a bathroom break during notes. Okay. Anyways, write an equation in slope-intercept form. So, from the graph, we are trying to write an equation, y equals mx plus b. Y-intercept is 2. So our b is going to be 2. Slope, they plotted 2 points for us, so we can just go up 1 over 1. That'd be 1 over 1, so our slope is just 1 over 1, which equals 1. Whoa, it's blurry. Y equals, technically 1x, but we usually don't write that 1, plus 2. The next one, our slope is 4/3. That's going to be our m. It says it passes through this point 0, 4, which you may notice is your y-intercept, so b is just going to be 4. However, we're going to do this the long way because no matter what point they give you here, you need to be able to get it into slope-intercept form, and the way to do that is through the point-slope equation. So we're going to use the point-slope equation for this one, even though you could shortcut this and just say your y-intercept is 4 and plug it in. But the point-slope equation is y minus y1 equals m times x minus x1. And no matter what point they give you here, whether they gave you the y-intercept or not, you could use this equation to get it into this format. So using this here, y minus 4 equals our slope, which is 4/3, x minus 0. So this would be your x1, y1. And then we are just going to solve this, rearrange it until it looks like this. So y minus 4 equals 4/3 times x is 4/3 x. 4/3 times 0 is just going to be 0. And then from here, add 4 to both sides, and we get y equals 4/3 x plus 4. And that's our answer. Next, it's saying, what's that?
So I'm still comfy.
Oh, okay. Pause. Yes.
What happens to that 0? Aren't you supposed to multiply that 4/3?
4/3 times 0 is just 0.
Yeah, so why'd you write it?
Well, 4/3 times x is 4/3 x. And then I didn't do the 4/3 times 0. Yeah. Okay, next it says a line passes through these 2 points. It wants the equation for the line. Well, we need to find slope, and we can do that by slope equals y2 minus y1 over x2 minus x1. So we're going to do that first. Taking these 2 points, subtract our y's, subtract our x's, I get negative 4. So m equals negative 4. I could use this equation, but I notice I have my y-intercept right here where x equals 0, and that's our y. So using that, we can just say y equals negative 4x minus 6. Yes,
If it didn't give you like for the
y-intercept.
yeah, if it didn't give you
You would use this.
okay.
Yeah, you would put in your slope, you'd put in one of the points, and then just solve it, and it would come out to this. Yes.
Do you know that it's negative 6 is on 10?
What's that?
Did you put the 10 instead of the negative 6? That's also
So I subtracted the y's. 10 minus negative 6. Wait, what do you... Oh, could you have used this? No, because this isn't the y-intercept.
how do you why? How do you know that?
Well, I know this is the y-intercept because x equals 0, and when x equals 0, that's the y-intercept. But if you didn't have the y-intercept, you could plug in one of these into this equation, and it would come out to the equation you need. Okay. Now, parallel and perpendicular lines. I know this comes up in algebra. It also comes up in geometry. So I hope this is kind of a review. If it's not, I'll explain it. Parallel lines have the same slope, and of course they never intersect. So here it shows an example. We have the equation of a line here, and they both have the same slope of 5. So that means that these two lines are parallel. Whoa, it almost froze on me. Okay, perpendicular lines have slopes that are opposite reciprocals. So if I have a slope of 5/3, a line that is perpendicular to that would have the negative reciprocal of negative 3/5. And it shows that in these two equations here. So opposite means opposite sign. So if it's positive, it turns negative. If it's negative, it turns positive. Now we're going to do 2 practice problems with this. It says write an equation in slope-intercept form, that's y equals mx plus b, for the line that is parallel to this line and has an x-intercept at 2. Okay, so parallel means it would have the same slope, so our slope is going to be 3/4. X-intercept at 2 would be 2, 0. That would be the coordinates. Because it's not a y-intercept, we can't just plug it into the equation. We actually have to solve. We're going to use the equation y minus y1 equals m times x minus x1. And we're going to plug these points into the equation along with the slope, and that will give us y equals mx plus b format. Let's see, where am I going to do this? I'll do it over here. So y minus 0 equals 3/4, and then x minus 2. And then I will simplify and solve. So y minus 0 is just going to be y equals 3/4 times x is 3/4 x. We're getting there. Then I have 3/4 times negative 2. Uh-oh. We're going to multiply the fraction. So 3/4 times negative 2 over 1. So I'm going to simplify before I multiply. Negative 2 and 4 can both be divided by 2, so I get negative 1 and 2. 3 times negative 1 is negative 3 over 2. Do you want me to do that again? Are you okay? Okay. So we get negative 3/2. Yes.
When it says parallel in the question, what purpose does it serve?
To tell you the slope. So it says parallel to this line, so you know you're just pulling the slope out of that equation. Next one, write an equation in slope-intercept form for the line that passes through -9, -3, and is perpendicular to this. So perpendicular, the slope is a negative reciprocal, so, or opposite reciprocal, so it would be positive 3/5. So for the line, we are going to determine the slope's going to be 3/5. It says it passes through this. We need the y-intercept for slope-intercept form, so we have to use the point-slope form to find that. So y minus y1 equals m times x minus x1, and then we'll plug everything in. Y minus -3, our slope is 3/5, x minus -9. If you're thinking this isn't going to be pretty, it's not. Okay, so we'll start somewhere. Subtracting a negative, that's y plus 3. 3/5 times x, okay, I can do that. This is adding an opposite, so this is going to be positive 9. 3/5 times 9, we're going to do that off to the side. 3/5 times 9, but 9 over 1. There's no way to simplify, so 3 times 9 is 27 over 5. So you get plus 27/5. Okay, we're getting somewhere. It's looking close, but problema, we have a 3 over here. We have to get this over here. So subtract a 3 from both sides. We have 27/5 minus 3. So 3 over 1. When subtracting fractions, we need a common denominator. Right, so we're going to multiply this by 5 and multiply this by 5. 15 over 5. And then we get 12/5. So then rewriting this, y equals 3/5 x plus 12/5. And then we're actually done.
For the day or that page?
For the notes for today. So the rest of the class you'll have to work on homework on Schoology, which is 2-2. Now the homework on Schoology for 2-2 is mostly this, like determining whether a line is linear or not, and then making equations into standard form. So that's what you need to focus on today. The homework tonight is 5 questions. So you can use your phone, get your homework done in class if you can. If you have questions, let me know.